I'm a computer scientist interested in questions of governance around software systems, computer systems generally. I often say software systems, and I occasionally get some flack from colleagues for not including hardware, but to be fair, those colleagues are cross-appointed in the electrical engineering department, so that is sort of their want. I want to talk today about talismans of governance. I'll describe what that means in a moment. But I want to start by acknowledging some collaborators. This work is joint work with Abigail Jacobs from the University of Michigan and Stuart Geiger from the University of California, San Diego. It started when all three of us were working in various capacities at UC Berkeley. So that's how we got going. But to start us off today, I want to take us back in time, back almost 50 years, back before a president said, "I am not a crook," back before Queen Elizabeth oversaw the opening of the Sydney Opera House, back before a brash New York real estate developer was first sued under the 1968 Fair Housing Act for discrimination in rental housing. Back to 1973, so those paying attention might have noticed that all of these events are from 1973. Another event in 1973 was the formal adoption of this report from Willis Ware's committee convened by the Secretary of the Department of Health, Education, and Welfare called Records, Computers, and the Rights of Citizens. And the thing that we know this report for today is it is the place where the 5 fair information practices or fair information practice principles were first articulated. And so people sometimes call these the FIPS, but I want to summarize just the first 2 of the FIPS by highlighting what they mean, which is the FIPS demand that citizens must know the existence and the scope of any data processing that is done about them. And the rest of the FIPS deal with sort of people's agency around that knowledge, around the knowledge that data processing is happening. And this is important because if we move in time again, if we move to 1974, we not only discover the first all-California World Series in which the Oakland A's blew out the Los Angeles Dodgers 4-1, but we discover the passing into law of the Privacy Act of 1974. Which takes those 5 fair information practice principles and enshrines them in law, at least for systems operated by the US government. So this idea of the existence and scope of data processing systems being transparent gets into law in the Privacy Act of 1974. It can then be traced both textually and conceptually from there into basically all modern data protection law. So it finds its way into the OECD data protection guidelines, which are adopted by many countries as the baseline for their data protection law. In particular, the OECD guidelines have a strong influence on the 1996 EU Data Protection Directive, which requires all EU member states to pass national laws meeting those guidelines. That directive is eventually superseded by the General Data Protection Regulation. And the GDPR and the directive are both, or certainly the directive and the guidelines are important in the drafting of something called Convention 108, which is a sort of international data protection law harmonization treaty that is promulgated by the Council of Europe and defines data protection law in a number of non-US EU countries. But then also in the US, we have now the California Consumer Privacy Act and soon the the new version of that, whatever it's called, the CPRA. And all of these things derive in various ways from these fair information practice principles that come from the 1974 Privacy Act. And all of these laws in force all around the world demand some degree of transparency about the existence and the scope of data processing. And later law also introduces other transparency requirements. So the GDPR has these clauses about the meaningful information about the logic of processing that subjects should be able to get. Some version of that clause was also in earlier versions of the document. There are transparency requirements in French administrative law and in various US state laws as well. So there's quite a lot of legal justification for transparency is the point that I'm trying to make here. And a response to that people have given is to push for various kinds of standardized or structured disclosure documents. So you see just a big slew of calls for this, sometimes from companies, sometimes from academics, calling for things like data sheets for data sets, or there's an alternative standard called model cards for model reporting, or fact sheets for AI services. That one comes from IBM. There's a group that has promulgated the idea of data set nutrition labels. I've seen a proposal recently for Energy Star ratings around these kinds of services. And lest you think that I have created an AI ethics talk in disguise as a governance talk, I want to point out this very recent report from the National Institute of Standards and Technology, now finalized, on validating the integrity of computing devices throughout the supply chain, which basically calls for the creation of standardized disclosures about supply chain risk management procedures from vendors that can be passed through a supply chain from an original equipment manufacturer up to a final consumer of a piece of technology, whether that's software or hardware or a component. And we also see, in addition to these kinds of disclosures about AI, disclosures about software decision-making systems, disclosures about supply chain, we see also the effort to certify under standardized requirements organizations and their security posture. So you have things like the Payment Card Industry Data Security Standard, the ISO 27000 series, the SOC series of standards, which is managed by accountants who clearly have a lot to tell us about cybersecurity certification, right? Famously, accountants very good at cybersecurity. And I think we'll hear more about this specific area tomorrow. There's a talk by Danny Weitzner that I'm certainly looking forward to. Within government, we also have this process based on the NIST Cybersecurity Risk Management Framework, sometimes in industry just called the Cybersecurity Framework. And under that process, at least in the Department of Defense, we have a separate certification process called the Authority to Operate process, the ATO process, which basically requires a risk analysis under the NIST framework and then certifies that a network has put in place appropriate security controls commensurate with the risks identified during that risk analysis process. And because that happens in government, it implicates other legal justifications like FISMA. And in the private sector, there are other legal drivers here, the FTC Act being a major one under the Wyndham standard. But we take all of this activity and it turns into a multi-billion-dollar industry. So just to give you a sense of what I mean by a multi-billion-dollar industry, that ATO process is estimated to cost the Department of Defense about $7.7 billion a year. And it's estimated that on security certifications in general, industry spends about $84 billion a year. So this is not a small activity. And this question of, can we adapt these kinds of structured disclosures or standard disclosures to things like fairness in or non-discrimination in AI is an interesting question, because as we sort of go through these efforts, we really haven't ever answered the question, why are we doing this? What is the purpose of all of these disclosures, and do they make anything better? And I would argue that we have no idea the answer to that question, and therefore what we are doing is creating talismans, sort of documents that we value for the belief that they are making things better, rather than any actual evidence that we're making things better. So leaving aside the question of how we would generate that evidence, which is a difficult and hard question that there's a large research literature about, I want to talk about the governance implications of this activity and how it affects organizations. And that will get me to a place that I hope is interesting for some discussion, because this is somewhat early stage work. This is the first time I've talked about this work in a public setting, and so I want to get some feedback from the community. But often, looking at these processes, I'm reminded of what is sometimes called the politician's syllogism, which is we must do something. This is something, therefore we must do it. And in specific, by that I mean that if some system has a functioning governance process, that process probably knows some facts about the system, and it probably writes those facts down. And for convenience, the form in which those facts are written down is probably standardized. To say that we should introduce standardized forms of disclosure to cause governance is to confuse the direction of causation, right? Good governance is happening, and it is producing standardized structured disclosures. Standardized structured disclosures are not of themselves producing functioning governance. And the reason for that is that there's a real gap between the goals in policy of these kinds of structured disclosures, which and the reality of the disclosures as they are actually put into practice. So in policy, the kind of highest goal of these disclosures is to provide information to affected citizens and to competent oversight authorities, really to match that Privacy Act existence and scope mandate. And further, to combat opacity in these systems, to say that the people who control and manage computer systems really aren't showing all their cards, and it's quite hard for an outsider to understand what they're doing, maybe harder than it would be if decisions were made by a human-operated bureaucracy, although maybe not actually harder, just you know which human in the bureaucracy you have to go ask to get more information, whereas it might be harder to interrogate the program itself. But I would argue, and I have argued, that opacity is not due to any specific opacity of the design of the system or the nature of the use of software, because the controllers of these systems always make decisions to say the systems are adequate to the purpose that we're putting them. And so really, opacity is always a sign of power asymmetry. So disclosure is really meant to try to put affected citizens and oversight authorities on a kind of level playing field with people who are meant to be governed by these disclosures. Often we talk about these disclosures as a way of building trust or supporting some other governance goal, right? We want to have these data sheets or these model cards for our AI systems because we care about discrimination or we want to know that we can rely on these systems in certain cases. We want to know that our credit card information is going to a company that has successfully gone through a PCI DSS audit, so that we can say that we trust that we can give our personal financial information to that company, and they aren't like a thin front for the Russian mob. Maybe like a thicker front for the Russian mob, where the Russian mob actually has to hack into their machines. Kind of the final goal is that the disclosure is supposed to be a true, honest, and full accounting of a system and how it works. And more you see in things like AI ethics principles, calls for what gets called traceability. Traceability is often seen as a kind of enhanced transparency, saying, let's take this transparency and build it up with some standard disclosures and figure out, not only what all is happening, but why it's happening and where it comes from. I would say that, again, the point of this transparency is really to enable governance, enable holding people responsible for what the system does. And so that's a goal. It's a very lofty goal. It's perhaps more achievable goal than other kinds of things that show up in these AI ethics principles documents, right? You could imagine starting to approach traceability by asking questions about the reproducibility of model builds or the reproducibility of software builds, which are at least technical problems that we can approach solving, as opposed to something like we won't discriminate, or our systems will be equitable, or our systems will be fair. Well, exactly what that means in operationalization might depend on where you sit or how you relate to the system. And so it might be contested, or even essentially contested, in such a way that it's not possible to, or it's not as straightforward anyway, to find a good operationalization of that principle. Which makes actually setting up systems at the scale of the internet or very large organizations, governments, very challenging. So I'm going to turn to the reality of how disclosures actually work in real systems. There's a phenomenon that I would describe as the compliancization of these disclosure systems, right? So there's sort of two ways to look at your PCI DSS audit. You can say, well, this is an opportunity for me to organize all of my information about the information systems in my organization, to figure out what they all are, where they all are, how they all work together, and how they can work together in a way that is secure and consistent with my goals of not being hacked by the Russian mob. Or you can look at it as a barrier you need to pass in order to be able to take credit card payments and charge your customers. You can guess which of those two approaches is the more common one in industry. And so in the security industry, there is a real disdain for what people call the box ticking mentality of security, right? That we somehow go down this list of 100 and something things that the PCI audit checks for, and we verify that we can convince the auditors that each one of those facts is true about all the information systems in the organization, at minimum cost to the organization. And so we don't record what is, we record what seems right, or what convinces an auditor. Also, disclosure documents are documents. They're a kind of documentation. And there's a culture in the tech industry where everything is constantly in beta, that some documentation may be out of date. This is a joke inside many tech companies. People will complain that the documentation doesn't reflect what the system actually does, and the response is kind of sardonic. Some documentation may be out of date. Lots of software actually ships to consumers with some disclaimer that says that some documentation may be out of date. It's not too hard to find such a disclaimer if you sort of poke around the internet. The next point I wanted to make is that opacity, which is the thing that that these disclosures are meant to combat, isn't a problem for the people inside the system, right? They understand how the system works. They believe that it's fit for its purpose. And so they're not quite sure what exactly they need to disclose in order to combat opacity for other people. There's just not visibility into what is invisible. You don't know what you don't know. Another point is that if you have a document, that document can become a talisman of everything's okay, right? It can stand in for the claim that nothing is wrong. If the structured disclosure document doesn't say there's a security violation or doesn't say there's a kind of discrimination or an unfairness in the output of a model, then it's very easy to sort of shake that document in public, especially in a context where the document describes some system that's fielded by a government and it's happening, say, at a public hearing, right, to wave at a legislator and say, look, we did an assessment and the assessment says everything is fine. You can read the report. And that's, I think, the real worry here is that the documents, that there's a push toward these documents, but the documents don't actually tell you what's really happening and can paper over real problems that that governance or accountability structures need to be able to see. And a final point is that it's often the case that organizations will adjust their behavior or redesign a system to limit what they have to disclose. I mention this only because it's a criticism that people levy against things like environmental impact assessments, that people will redesign, say, a power plant so they don't have to disclose certain kinds of things in their environmental impact assessments. And you might argue, well, look, they're just sort of raising themselves up to meet whatever bar of disclosure there is. But maybe that's not a problem, right? Maybe the thing we wanted the impact assessment to do was get the organization to change its behavior, to get it to a point where it wasn't doing something that was so bad that it had to be disclosed. So that's a phenomenon in the real world, although maybe it's a problem, maybe it's not a problem. It's just sort of worth watching out for. So coming back to the theme of this workshop, I want to make the point that governance is a co-evolutionary process, that we need to develop the objects of governance, these structured disclosure documents, and the policies that tell us how these things have to work, and the structures that are going to take them and interpret them all together. And so what we really need to do is see the whole process as a single system and do engineering on that entire system. That includes the people who are actually ingesting and interpreting these documents, and also the human users of the system. So I guess three major ideas here. The first is something that people sometimes call Felton's third law, which is the practical problem that technologists often see the requirements when faced with a legal issue as coming from policy, right? So we write down what the policy is that applies to the system. We then think about that carefully in a requirements engineering setting. We come up with a set of requirements which define how the system should behave in every condition, and we build that. And then we can verify against that specification. And that has certain advantages, but also certain limitations, because software is somehow inherently always going to pre-adjudicate every situation into a set of rules. So I was teaching during James and Solon's discussion this morning, but I'm hopeful that they talked about sort of rules versus standards issues around software, and questions of how you would formalize legal requirements and whether those are always achievable. But there are real gaps there, I would argue and have argued. And on the other side of that Felton's third law coin are the policymakers, who often make assumptions that they don't need to articulate specifically in policy everything that's going to happen or to solve some trade-off in policy, because the technologists will come up with a solution, right? So this is happening again around encryption in the EU as we speak. There is a draft legislative proposal arguing that technologists need to find a way for law enforcement to get access to encrypted communications, but it's not a backdoor. But it's not a backdoor, not because it's not a backdoor. It's not a backdoor because the legislative proposal explicitly says we're not asking you to create backdoors. The technologists in the room are presumably all laughing. Hard to tell in a virtual environment.
I'm laughing, Josh.
Joan is laughing. Great, thank you, Joan. So the second kind of big idea that I think maybe came out of my last slide is the idea that writing things down isn't the same as doing them. So the big example of this for me comes out of a book called The Challenger Launch Decision, which is about the making of the Challenger launch decision, in which the engineers were all very much aware that the launch was likely to be unsafe, but their views were sidelined organizationally because of organizational politics and because the organization wanted to be able to certify the launch. And so no rule and no disclosure can be stronger or more meaningful than the organization intends it to be. One kind of corollary of that is that the organization, if the organization is going to write things down in any kind of structured disclosure document, a model card, a data card, nutrition label that goes out to customers, a privacy policy, the contents of that need to be audited internally so that the organization knows what promises it's making, and maybe need to be audited externally or overseen by a regulator. So that's just a way of reifying the gap between what happens in reality versus what the organization is willing to enforce. You might think that that gap can be shrunk in other ways. So I've written here safety cultures. Lots of organizations that deal with safety critical systems develop what we call safety cultures, where they think about safety on a regular basis, and where they, for example, I have students who are submarine officers at the Naval Postgraduate School, and they tell me that when some incident happens on a submarine, rather than figuring out who did something wrong and blaming them for doing something wrong, the question is, how do we keep that bad thing from happening again? So the culture is, rather than the sort of standard military culture of, everyone is responsible for their actions, it's, we are all a team, we're all on this boat together, we're all trying to keep this boat running. Let's make sure we know how to keep this boat running safely. So the last big idea is an idea that I sort of alluded to a second ago, which is that when we see the intervention as one of these structured disclosure documents, right, we're going to solve supply chain risk management by standardizing the format of supply chain disclosures from vendors to customers. Well, that doesn't help, because that sort of sees the problem of supply chain risk management as a problem of information moving between entities in the system. But it kind of elides, how does the whole system work? How does the whole system uphold the outcomes we want to happen? How does the system avoid accidents, right? So oftentimes we see accidents as the result, not just of failure of a component, right? Some entity in the supply chain was undermined, right? Somehow device was pulled out of the UPS package flow and tampered by someone, UPS, the Russian mob, National Intelligence Agency, someone. But really, we might ask, how does the whole system that we're building react to that, right? Why is it that one tampered piece of hardware can violate our security policies? Why is it that pulling a package out of the UPS system isn't somehow visible to us in a way that is, reasonable or coherent? Why do we trust these carriers not to allow that to happen? Can we, say, put a seal on things before they go into the system and then check the seal when it gets out? And similarly, we can think of that systematic view as relating to this question of who is this documentation for and what are they supposed to get from it? And so sort of going back to that idea of accidents, I want to close by talking about accidents because I've recently become fascinated by what I'm calling automation accidents, which are accidents that come from the relationship between humans and automated systems. So there are a few standard problems that cause these automation accidents. A common kind is mode confusion, where a user is unsure of exactly what an automated system is doing. Another is automation complacency or passive vigilance, the idea that you have to pay attention to a system, but the system is doing everything for you. So you have to be vigilant, but also you're not actively taking part in any of what the system is doing. And the final is automation ironies, which is the sort of similar to this passive vigilance problem, that automation robs you of experience in doing what you're supposed to do. So if you had a self-driving car, for example, then maybe over time you would forget how to drive, or you wouldn't have as much experience driving. So if the car suddenly gave you control in an unusual or difficult situation, it would be challenging for you to actually take over, not just because you don't have situational awareness, but because you don't know how to operate the car safely in that situation. And we talk about this in a lot of systems with some kind of autonomy, so autonomous cars, autopilots, auto steering systems for ships. This picture on the left is from a crash of a Navy ship, U.S. Navy ship called the USS John S. McCain, which hit a chemical tanker, the MV Alnick, a few years ago, in part due to an auto steering system and automation complacency and mode confusion around the use of that auto steer system. But where we don't talk about this a lot is decision support systems, right? If I give a doctor a score about what to do with a patient, and then the doctor makes the final decision, or if I give a judge a score about what to do with someone who's been arrested who might need bail, which is now the law in California, or the law will anyway be allowed to take effect. It's been on the books for a while, but it was held up by a referendum, which has now concluded. How do we know that the judge isn't somehow made complacent or confused by the automation? And so really we need to take that kind of whole systemic view of how the information we need in the system works and who's meant to consume it. I want to close, I'm out of time, but I'll close by mentioning that I've given a kind of bleak picture, but I actually don't think the picture is all that bleak. There are lots of places where structured disclosures work really, really well. So I mentioned that security practitioners are really skeptical of checklists. Also, surgeons were really skeptical of checklists in the operating room until they became mandated standard procedures, and now they're somewhat indispensable. And similarly, pilots and other vehicle operators who work in high safety critical situations are often resistant to the use of checklists because they feel like their expertise is being babysat unfairly. But actually, we know from those domains, from studies on those domains, that checklists really do reduce the number and severity and complexity of accidents. That they really make sure that all of the kind of the low-hanging fruit is protected or prevented, that any kind of easy problem is solved. Another place that structured disclosure happens and is useful is in near-miss reporting or incident reporting. So in various military applications, in aviation, in medicine, actually in several places in medicine, there are incident reporting procedures or databases that are maintained. So, for example, in pharmaceutical studies like the COVID vaccine trials, but really any pharmaceutical study, there's side effect reporting that goes into incident databases during clinical trials. There are incident databases for adverse events that happen during the trial. That data gets rolled up and considered in the safety evaluation for the medication itself. In aviation, when there are near misses, those happen. They get promulgated out to operators within the system, and the operators now know sort of where to look for problems or how to augment their training to understand what might go wrong. And then finally, there are sort of holistic risk management programs for domains where we do have ways of measuring risk. So I said that I was going to leave aside this question of whether we could measure risk. And let's just imagine that security or fairness are places where we don't have ways of measuring risk. But there are other places where we do have ways of measuring risk. Often in the financial industry, for example, we can measure risk in dollars. And even if we get it sort of hugely, massively wrong, like happened in 2008, you can always proxy any risk in the financial industry into a number of dollars. And you also have competent regulators who understand deeply how those risk management calculations are made. They might not understand the subjects of those risk management calculations, like collateralized debt obligations or certain kinds of commercial paper that went south in the 2008 crisis. But there are governance regimes that control those risk management processes, like the Federal Reserve's SR 11-7 model risk management framework approach. I'll conclude with the idea that trustworthiness, the thing that maybe we're trying to get out of these disclosure processes, happens when nobody asks if there's a problem. So I like to give the example of the building code, right? You never walk into a building you've never been in before and say, boy, I wonder if this building is going to collapse on me. You just assume that the building code and the building inspection process work together to create a system in which you can walk into a building in most countries in the world and believe really and truly that this building is going to be just fine, or you can climb up in a skyscraper to a very high floor and not believe that the whole building will come toppling over, unless you happen to be in San Francisco, where one of the skyscrapers is sort of slowly leaning over. In her book, Engineering a Safer World, Nancy Leveson gives this figure the general form of a model of socio-technical control, thinking of the technical understandings of how a system works, so these kinds of information that we get out of structured disclosure processes, together with things like law and policy, all kind of co-developed into a process where the control structure controls the whole system, not just individual components. So that's kind of where I wanted to leave it.
Do you want me to read the
Stop
question?
screen share. No, I got it. I just
Okay.
found it. How do you reconcile full accounting of systems in the technical sense with the state explosion phenomenon? Large-scale verification is only tractable because of techniques that reduce the space based on complete knowledge of desired properties, which would not seem to be reasonable for accountability in general. This is an excellent, excellent question. There are a couple of answers to this question about state explosion. One is I've seen some work out of the systems engineering community that describes what they call a small scope hypothesis, the idea that counterexamples can be found within a small scope, and so model checking a small scope can be enough to find counterexamples reliably. I'm not sure that I totally believe the argument that is made around this, but at least maybe you could find more targeted search approaches to find these counterexamples. Maybe there are small counterexamples, or maybe there are efficient counterexample search strategies. I think this is also a problem with the kind of theory of, I alluded but did not say, I alluded to but did not mention by name Charles Perrow's book, Normal Accidents, in which he describes these kind of interaction issues that the questioner is getting at. And again, I think we can, like, there are red lines that we can draw. You know, we believe that encrypting information moves the custody of that information from the text of that information, the bytes of that information, onto the bytes of the key. And in fact, that is a principle that's enshrined in law in various places. So for example, there's a Massachusetts state law that requires breach notifications for data breaches, and there's a safe harbor in that law if the data which were breached are encrypted in a sufficiently strong way that the adversary is unlikely to be able to break the crypto. Then that can be a way of limiting the damage. And so I think this state explosion is a problem. How you apply that in general is an interesting question. The answer may unsatisfyingly be, well, you have to think about it carefully for each system you build. It's not like there's a single finite element analysis that you can apply to any engineering problem in this space that we know of. I mean, maybe there is. Maybe we should go find that. But it's also possible that that doesn't exist and we can still do a good job. So that's where I'll leave that question.